Hey everybody, welcome back. So what we're going to do now is continue on with HTTP and start actually digging into the protocol itself. Now, if you can recall, last time we started talking about how URLs are formed, talking about the structure of how we get a web page. Now we're going to actually start digging into HTTP a bit. So the idea here that you're seeing on the screen is that we want to transmit resources. And again, what that means is that a resource is going to be anything that your client needs to render a web page. Classic HTTP, that again means that every single thing is going to be its own request. So I'm going to transmit the HTML code. There's one request. I'm going to transmit the CSS style sheet that I'm linking because it's a separate file. Another request. I'm going to transmit every single image that needs to be sent from the server to the client. Other separate resources, transmissions. Basically, the idea is that this is a request reply protocol, meaning that the client needs something, it requests it to the server will reply or respond with that resource. Now, this will be packaged up into a series of packets, which will be sent. That's part of the protocol, underlying protocol. But effectively, what happens is that this is stateless. And what this means is that we have no concept of a persistent connection here. I'm going to make a request, the server will respond, transmission done, right? There's not going to be this live socket where we're piping data to and from. That comes later. It does exist, HTTP 2 and beyond. Now you have this idea of a MIME-like resource response here. Basically, MIME is just how we are describing the content of the message. We'll see this in a little bit, but basically this is like, is it an HTML page? Is it a JavaScript page? Is it a style sheet? Is it an image? Is it some kind of data? The client and the server needs to know what type of file this is. And again, only one resource at a time. This is going to speed things up. Now, I mentioned stateless. There's no persistent connection. There is no memory, basically. Every request is separate. So there is like no dependencies that we need to worry about. I misspoke. I just realized this looking at my slide. HTTP 2 also has persistent connections, but HTTP 1.1 gives us the concept of a persistent connection as well. Now, what this means is that for you as developers, this is not going to make any big difference, okay? I could count the number of times on one hand that I've actually needed to maintain a persistent connection with like a standard simple web application. If you want to start handling like push requests, if you want to start being a little bit more complicated with your scripting, then it absolutely becomes important. But just like a standard blog style website without a whole lot going on, you're probably not even going to care here. But the idea is that HTTP 1 for the longest time was the standard. HTTP 1.1 comes along and we get persistent connections. You need to assume from the client side that this persistent connection will exist. And we'll talk about, kind of the flow of these responses and things like that very soon. But how do we get this idea of a persistent connection or not? It just depends on your server. If your server is running Apache that is configured for HTTP 1.0, you don't get persistent connections. If it's configured for 1.1, you do, and you can actually watch that in the network traffic. So I kind of mentioned this in the last slide, 1.0, 1.1 to, getting towards 3 probably soon-ish. If you're a normal developer making standard, straightforward websites, you're not really going to care. It's once you want to start digging into, some of the more network-oriented operations that you will care. I've got a nice link to a Stack Overflow post here about some of the differences, which I would, definitely recommend reading into. Obviously, it's community sourced, but there's a lot of really good responses in here. So, enough, getting around the issue. Let's actually talk about what HTTP comprises. So our message structure is basically going to be, if you actually look at the traffic, we're going to have some headers. We'll have a blank line, and then we'll have the body, okay? So it's going to look something like this. We're going to see a method with a path, with whatever version of HTTP we're using. We're going to have some headers, our blank line, and then our request body. Okay, and what this is going to look like is something along these lines. So I took this from Mozilla. I'll show you in a minute a live demo. But basically here, to break this down a bit, right? Headers blank line body. So here's our method. It's a post. It's at the root, and we're using HTTP 1.1. Where's the host? Localhost :8000. So this is our own server. So this is like a development server running port 8000. But basically, here's our header block. Again, host is part of the headers. Who is browsing to the site? Well, it's a Mozilla Firefox browser version 51. This kind of becomes important for those of you developing websites where you have to consider different browser types, right? Okay, what are we accepting here? Well, we're expecting HTML code basically, or, a bit more. And then, basically a whole bunch of other information as well. What's the language? What's the encoding? Things of that nature. Okay, connection, keep alive. Upgrade and secure request 1. So we have a connection here, right? And then we have some more specific form-related data, or content-related headers. And then after that, we get into our body message. So this would be for a request. I want a resource. So I'm sending this packet to a server. Similarly, we'll get a response back. I send a request. Here's my packet. Send it off to the server. Server will respond back with whatever you requested. Now it's going to look very similar, except we're going to get a status code and explanation and then a response body. So here we see, okay, HTTP 1.1, 200, okay. This means that the server successfully handled your response and you are getting data back. Then we have, again, a lot of header information here, and then we get into the body of the response. All right, so we can get through, if you want to dig into some of these, that's perfectly fine. We'll talk about them as we need to. You don't have to memorize every single header, but they're good to know. All right, so when was this last modified? Okay, 2016. Wow, this is an old packet or an old request. Old resource to be requested. So we have these headers here, right? And make sure I'm in the right spot here. What I wanted to show you was that you can actually watch this in your browser. So again, I'm using Chrome. All right, and what I'm going to do is I'm going to pop open my DevTools, Control-Shift-J or I, depending on if you're Chrome or Firefox, respectively. I'm going to go to my Network tab here, and I'm going to go back to the School of Computing homepage. Now, in here, I see every single request that has popped up. Right, so this is really useful for debugging, by the way, if you're trying to make make a web application and you're trying to figure out why something's not showing up. Maybe the server is refusing it. If I have, I want to load in jQuery and I'm not getting a response of 200, something's wrong. You'd probably also see that in the console though, honestly. But if I pop up here to my main resource that I want, here's my web page, okay? Again, once you click on these various resources, you can get more detailed information. So here's my HTML page. Here's my header. Okay, what's the request URL? Method, status code, address. Here are all the things that we are saying in those screenshots, right? 200, okay, great. How did we get this data? Through a GET call. All right, do we have any caching that's going on? When does this thing expire? What server is it coming from? And then a whole laundry list of information about, other information here. Here's my response that I got. Hey, it turns out it's HTML. Oh my goodness, right? So here is where we can really dig into our various, HTTP messages. Highly, again, recommend getting into understanding the dev tools if you are going to be a web developer, because that's where you're going to get your debugging information. Unless you're using something like Postman or something like that to debug a more complicated web application. Okay, so let's talk about some of the ways we can get and send data. Now, get and post are two that you're going to see me do a separate demo on. Basically, we want to get a resource of some kind. Now, get will send it through the query string, post will send it through the form data. We will see that separately. If we were to say send a request for head, let's get the web page header. If it's put, I'm going to send some file to your server. Delete, I'm going to get rid of it. Again, you can kind of go through all of these different methods and really understand what they are. But let's kind of look at get here. If I'm running a get call, I want to retrieve a resource with some query string data. Again, you're going to see this. I'm going to use PHP to demonstrate it. Very simple script, but I'm sending some data to my server via the URL bar. Okay, so it's going to be populated as a query string. From a header perspective, it's going to look kind of like this. So I would send get, okay, so what's the path, /index, question mark, and then my list of parameters. What protocol are we using? What's the host? What's the user agent? This is not what you program with HTML or PHP or anything like that. This is what the handshake between the client and the server is. So when I send my form data, this is the thing that's being packaged up and sent to the server. All right. Similarly, with post, it's going to do a very similar idea, except the header is going to be post, and then we're also going to send the content inside our packet for our header information. Our header and our body information. But hopefully the idea makes sense, right? This is what's happening behind the scenes when you create a form, right? So some other things to talk about here. So we have get and post. We have our head method where we're getting a page header. Wrong slide. So in here, instead of sending all the body data, so we're not getting the HTML page, we're not getting the images or the resources, I just want your header information, okay? And the reason why you might want to do this, you might want to debug, you might want to understand the page type, you might want to do some caching or security, maybe see when the page or resource was last modified. Basically, if you just want to kind of go through the page metadata, this would be one way to do it, all right? And to kind of give you an example of this as well, let me pop open a terminal here. Now, I'm running Ubuntu in Windows subsystem for Linux. All you really need to understand here is that I'm going to use the curl command. Now, what curl does is it's going to basically talk to some remote resource much in the same way that your browser talks to a server. This is just a terminal-based way of talking effectively. I can't remember if it's built into PowerShell. I think it is now. Curl. Yep. Okay. So if you're a PowerShell user, you can try this out as well. I'm not going to play around with it because it's probably not going to work. But what I'm going to do here is I want to say curl, and let's get this page here. All right. So curl our website. For reference, this is going to look absolutely terrible because it's everything. All right, so here we see our body of our request. Let's see if I can scroll up. I don't know if I have enough buffer for this. Yeah, it doesn't even, oh no, okay, it just froze. All right, so here's all of our script information. Yeah, there we go. So basically by default, curl is going to give us the body. Not seeing the headers here, right? But what I can do is curl -l-i. So the L parameter here is going to basically handle redirects. Not really necessary for this example, but can't hurt. But the important one here is -i, just give me the headers. All right, so if I send that, what I'm going to get back are the headers that I would see if I request something from this web server here. Right, so it's okay. Here's the server information. Here's the backend. When does it expire? What's our cache? Hey, our connection's no longer open because our transaction is done. Simple curl call doesn't need a persistent connection. And yeah, other information. Interestingly, you could use this for other purposes. If I want to say, understand what server type, or sorry, what server software a server is running, maybe if I'm doing like cybersecurity type things, hey, this might be an outdated version of Apache. I can attack it. Separate class. Don't use this for bad purposes, but you can get a lot of detailed information here, right? All right, exit out of there. Back to our slides. All right. Probably as good of a time as any to stop before we dig into status codes. I'll be back, and we'll talk about response codes very soon. Bye, everybody.